Okay, let's go over the answers to the questions that I gave you. Well, I guess it was this morning because it took so long to load. I think that website's getting bogged down or something. Man, it's taking forever. So these are the problems I gave you on the last video, right there. Okay, so let's go over the answers to that. Again, I'm going to have my periodic table, which I put away. Hold on a second. Okay, so I have my fancy 8th grade periodic table. Okay, so 7th graders, you can look forward to doing this next year. Okay, but again, you just need a simple periodic table to do this. Let's see here. I'm going to write the question down just to keep myself organized. Neon. Remember, the main reason why people struggle with this stuff is because they're lazy and they're sloppy. So don't be lazy and sloppy. Okay, you got to do this one step at a time, or you're going to get it wrong, and you can't be wrong. Okay, so I'm going to put my 13.3 moles of neon. I'm going to put that over 1. Oh, I was thinking too, sometimes you'll see chemistry teachers just put a multiplication sign here. Don't get freaked out when they do that. I was taught with parentheses, so I'm going to use parentheses, but sometimes you see the multiplication sign there. I like the parentheses because it kind of keeps things all snug and tidy. Okay, so now I need my conversion. Okay, so neon. Okay, so 1 mole of neon. I come to my periodic table, and it's I'm going to say 20.2 grams of neon. Moles cancels out, and now it's just a simple multiplication problem. Probably should get something better than a construction calculator for this, but it's pretty easy. 13.3 times 20.2. Oops. 13.3 times 20.2. Okay, so 168.66. Okay, so no, that's okay. I was going to go over the significant digit thing, but we'll steer away from that. Let's just make it easy. So 268, we'll just say 0.7. This is to the 10th. This is to the 10th. We'll just write it to the 10th. So that's not necessarily right. Grams of neon. Teachers love it when you circle the answer too, so we're going to go ahead and do that. So that's what you should have gotten for the neon one. So I've got 9.6 moles of sodium. Let me turn the radio down a bit. Over 1. And so 1 mole of sodium has a mass of, I'll just say 23 grams. Remember, I'm getting that number from the atomic mass. And at the end of the video, I'll go over what the atomic mass is a measurement of, just for those of you who don't know. So that equals, let's see here, 9.6 times 23 equals 158.7 grams. Make sure the teacher can see the decimal point. Okay, there's that. 5 grams, we're going to go the other way now. 5 grams of platinum over 1. Now let's see what our grams are here. Platinum is 195.1 grams of platinum for every 1 mole. So when it's division like this, I like to, multiplication isn't a big deal, but when it's division, I like to actually write it out. So 5 grams of or 5 moles. Grams is canceled out. Moles divided by 195.1. No unit has been canceled out. So now it's obvious that it's a division problem, which, you know, I kind of like to do. Just don't be lazy and sloppy. 5 divided by 195.1 is 0.03 moles. We'll put the PT, and we'll put the PT, just to make it all fancy. Moles of PT, and then go ahead and circle that. And then one more, 123.2 grams over 1. Oop. Make it fancy. Iodine. And my iodine number is 127 grams of iodine for every 1 mole. Grams of iodine cancels out, and I have 123.2 divided by 127.97 moles of iodine. So I hope you got those answers. Just in terms of the atomic mass, let's just go over that real quick. I'll just draw lithium to make it easy. So the atomic mass is the number of protons and neutrons added together inside an atom. So those go in the center. So 1, 2, 3, 4, 5, 6, 7. That atomic number is how many protons there are. So I'm going to put a plus sign in here for proton, and the empty ones are neutrons. So in lithium, there's 7 in the middle, there's 3 protons, and then there's 4 neutrons. And then the electrons fly around the outside in these electron clouds. But the electron arrangement goes 2 and 1. Why? Well, that's a whole other 4-week unit describing that. But the electrons don't really count much for the mass of the atom. The mass is all concentrated in the center of the atom. So the protons and neutrons added together make up the mass. So we would say that lithium has an atomic mass of 6.941 AMUs, and AMU stands for atomic mass unit. And an atomic mass unit is a proton or a neutron. So we can say that the atomic mass of the nucleus, or the atomic mass of lithium, is 7. But that's it. Okay, it's just AMU. Okay, and we use that mass again to convert into moles. Okay, so, and electrons don't count for much. Okay, trying to keep it short so that it downloads quick. Okay, so if you have any questions, let me know in the comments or the announcements, and I'll be back with another video soon. Okay, take care.